Okay, so we're going to look at how to balance redox reactions because balancing redox reactions are a little bit different than just balancing general chemical reactions. So on your how to balance redox reactions practice, you have all of the steps to balance. So you always want to make sure that you have the equations for both the oxidation and the reduction written out separately. Those are called half reactions. And then for each half reaction, we're going to go through everything step by step. And so you start by balancing everything except for hydrogen and oxygen, because then you balance oxygen using water and hydrogen using H+. Now that's assuming that we're in acidic solution. We're going to always make the assumption that we're in acidic solution unless it says otherwise. Then we balance the charge by using electrons. We make sure the electrons are equal, and then once electrons are equal, we add the half reactions and we cancel anything out like we've done with Hess's law. If it's in basic solution, what we have to do is then we neutralize the H+ that was added with the correct number of OH minuses to create water, and then we make sure everything is balanced. So we're going to go ahead and look at number 1. So number 1 is Ce4 plus Sn2 plus yields Ce3 plus Sn4 plus. So the first thing that you always want to do is assign oxidation numbers, because if your oxidation numbers change, then it's redox. If oxidation numbers don't change, then you would balance it like a normal reaction. So remember, when you have an ion, the oxidation number is the same as the charge. So Ce4 plus has an oxidation number of +4, Sn2 plus has an oxidation number of +2, Ce3 plus has an oxidation number of +3, because every time you have an ion, the oxidation number has to equal that charge. So then Sn4 plus would be +4. Now we have to look at the half reactions, and we have to split it up into oxidation and reduction. So we're looking at Ce going from +4 to +3. So if we have Ce4 plus going to Ce3 plus, the oxidation number is decreasing. And so if the oxidation number is decreasing, that means it's being reduced. So I'm just going to label this as the reduction half reaction, which means Sn is going from Sn2 plus to Sn4 plus. And so the oxidation number is increasing, which means it's losing electrons. So this is the oxidation half reaction. So once we have it split apart into the reduction half reaction and the oxidation half reaction, then we can go through these steps for balancing. So we're going to start by balancing all of the atoms except for H and O. So here we have 1 Ce, 1 Ce, 1 Sn, 1 Sn. So that's already balanced. We have no O's, no H's, so we don't have to worry about that at all, which means now we look at balancing charge. So in the reduction half reaction, we have Ce4 plus. So on the left side, on the reactant side, we have a total charge of +4. On the product side, we have total charge of +3. So we're going to add an electron to the more positive side to make the charges equal. They don't have to equal 0, they just have to be equal. So if I add 1 electron to the reactant side, I now have +4 minus 1, that's +3. This side is +3. And then in the oxidation half reaction, we have Sn2 plus going to Sn4 plus. So we need to make the charges equal. So I can add 2 electrons to the product side, because now if I have +4 minus 2, that gives me a total charge of +2 on this side, +2 on this side. So now I've balanced the charges using electrons. Now this should also make sense, because reduction is when something gains electrons. Oxidation is when it loses electrons, so it's a product. Now we want to make the electrons equal. So in the reduction half reaction, I have 1 electron, and in the oxidation, I have 2 electrons, so I need to make those equal. So think about what you'd have to multiply by to get them equal. I want to multiply this reduction half reaction by 2, because now that gives me 2 electrons and 2 electrons. So now I can add the reactions together, and I can cancel anything that's the same. So when I add these together, I'll get 2 electrons plus 2 Ce4 plus Sn2 plus yields 2 Ce3 plus Sn4 plus 2 electrons. So now if we notice, I have 2 electrons on the left, 2 electrons on the right. Those cancel, and there's nothing else that I can cancel. Now we're going to assume that this was acidic solution, so I don't have to worry about OH minus. which means all I have to do now is just rewrite what I had left over. SN2 plus yields 2Ce3 plus SN4 plus. There is our overall balanced reaction. Now just double check that everything works out. So I have 2 CEs, 2 CEs, 1 SN, 1 SN, and charge should also be balanced out. So I have plus 8, plus 2, so that gives me plus 10 on this side, plus 6, because I have 2 of them, and plus 4, that gives me a plus 10 on this side. So everything works out.